let's look at the symmetry operations of the square pyramid. If we look from the top of the pyramid, we can imagine the high order rotation axis goes from the peak down through the center of the base. The base of the Egyptian pyramids was very, very nearly perfectly square. We can see that if we rotate the pyramid by a quarter of a turn, the atoms along the bottom line up perfectly, and the atom at the top is along the rotational axis, so therefore it stays put also. So we see that the C4 rotation is a symmetry operation of the group C4V. Similarly, if we make a clockwise rotation of a quarter turn, 90 degrees, again we see that the atoms line up. It looks the same as it did before. Therefore, C4 to the minus 1 is also a symmetry operation of the group. We can also change alignment here slightly to make this a little easier to see. We also can rotate by 180 degrees. So if we make essentially 2 quarter turns, we see that again the atoms line up the same way they did before at the beginning. So we see that along the same axis as the C4 high order rotation axis, we also have a C2 axis, and they're coaxial. By the same token, if we go clockwise by half a turn, we see that C2 to the minus 1 is also a symmetry operation of the group. When it comes to mirrors, the square pyramid has 2 different types of mirror planes. The first type, called the dihedral mirror. Here we can see our pyramid all together, and then this line along here shows where the dihedral mirror is, and if we open up the pyramid along there, we can see that the 2 sides are mirror images of each other. So it's broken down. This kind of pink area on the inside is like the inside of the pyramid. So this is the dihedral mirror. It's a dihedral mirror because it passes between most of the atoms of the base. So while it goes through the atom at the peak, it avoids any of the atoms along the base. So that's why mirror, we turn around this way, we actually have a little label showing where the mirror plane is. We can accomplish the same thing with a smaller model made in pink here. And again, we can see that we can animate the mirror plane by opening along here. We can see where the mirror plane goes and exactly how it divides the figure into 2 equal parts. So that has the dihedral mirror. Now we also have a vertical mirror. Here we have another pyramid, and again, we have it lined up now so the mirror plane, instead of going between atoms, goes through 2 of the atoms of the base and through the atom at the peak. So we can open it up this way and we see exactly where the mirror plane operates. You've done it in a kind of false internal color to show that more clearly, and this is the vertical mirror. So there's 2 types of mirrors in the square pyramid. We have a dihedral mirror and we have a vertical mirror. There is one more point that we can make about the mirror planes in the square pyramid. We might imagine that this particular figure has a horizontal mirror, essentially in the plane of the square at the base. Now, if there really were a horizontal mirror plane, that is where it would be, because our high order rotation axis comes through here, and it will be normal to this particular plane. However, it's not a mirror, because if it were a true mirror, there would be one of these black atoms that we see at the top. There would also be one below the mirror plane here. Since there isn't, this tells us that there is no mirror plane through here, so there is no horizontal mirror for the point group C4D. Obelisks are another Egyptian religious structure with C4V symmetry. We can recognize the square pyramid at the top. You see that right here. Now obelisks actually have sloping sides. But even if they didn't, the obelisk would still have C4V symmetry. We can recognize the square pyramid right at the top. For a modern example of a obelisk, we can go to the Washington Monument in Washington, D.C. Another modern structure that doesn't look like an obelisk, but also has C4D symmetry, is the famous Eiffel Tower in Paris. So we can see that the appeal of C4V symmetry for public works has not diminished all that much in the last 4,600 years.